let's deal with this electrical circuit that you see on the screen, and let's obtain the equations and obtain the block diagram of this circuit. So the first thing we gotta do here is to establish the equations of motion. To do that, let's identify the current that circulates on the circuit like that, and then you first step, let's call it equations, the equations of motion or differential equations, right? So you can say apply Kirchhoff's law. And what does Kirchhoff's law says? What does it say? The summation of the current of the voltages across a loop equals summation of voltages in a loop equals to 0. So you're gonna have that in here. You have this, of course, is the source, the voltage of the resistor plus the voltage of the capacitor plus the voltage I, this minus V, that's a source equals to 0. Okay, so what we need to do, or said it in a different way, you could say that voltage of the resistor plus voltage of the capacitor plus voltage of the inductor should be equal to the voltage source. That's also another way of saying this. What we need to do is to establish the different equations for each one of the elements and then put them sum all together. So in here I would say that the voltage across the resistor, for example, this is the current I multiplied by the resistance. The voltage across the capacitor is 1 over C times the integral of I dt. And the voltage on the inductor is going to be I times di dt. Yeah? So if we put this all together, we could end up with this I times R plus 1 over C integral of I dt and then you have the other voltage for the inductor, I times di dt minus V equals to 0. If you put it in terms of, you see, this has integrals and derivatives, and we don't want that. We just want derivatives in here so we can solve this problem. dq dt in fact is the current I, where Q is the charge, yeah? So this means that dq dt times R plus 1 over C, the integral of I dt is the charge Q. So let's just write it down. This is 1 over C times Q. And the current would be plus I times t squared q dt squared. Okay, so that's the 3. You could say this is minus v equals. So I think what is best is to put the equation always in terms of the highest derivative. So we could actually, you could say, rearrange and write down that I d squared q dt squared plus dq dt times r. Now, what I meant to say is we need to leave this one by itself. So there was something funny about what I was doing here. Equal to minus, and then minus 1 over c times q, and then plus v, like that. So you see what happens if you have done this. I mean, the equation of motion basically is written here. This is basically the answer of obtaining the differential equation, this guy. But the answer regarding the block diagram, we need to do this. We need to put the equation in terms of the highest derivative. And every other term there will be a summation. So that's the thing. Now, how in the world is this gonna work? Let's draw in here our summation point. Okay. Let's draw our summation point. Perhaps I'm gonna help myself with some of the shapes. Let's start with those first. Maybe this one. Okay. How is that? And there you go. Just gonna use this other one too. Good. Okay. I think it would be a good idea to do this in here and write it down the way it comes out. So in here you have that this is I times d squared q dt squared and then we have the other terms like this. This is with minus and minus r times dq dt, and this would be 1 over c times q. So this is how we start here. This is the mg here. Not mg, what am I saying? This is the voltage here. The voltage. Okay, everybody okay with the transforming this equation into this little picture? The reason I ask you to do this is because when you have it like this in terms of the highest derivative, it's easier to draw the block diagram. That's why I'm doing this. So in here you have the, let's just go pick up one of these. In here you are gonna write down 1 over I. Now here you have d squared q dt squared. This is for doing integration. Same symbol. And if you do this, you get dq dt like this. And if you do it one more, you do it 1 over s integral of q. So you see, in order to complete this, I need to multiply by this dq that I have in here. So I could come in here like this, see? And then you have this one here. And then here this will go into here. This would be P. This is the Simulink that we could go. This is the file that we could take it to Simulink. Okay, so with this, it could be putting into a computer program here. That's how we generate the block diagram for the circuit.